Mount Spurr didn't explode, and that may be exactly why scientists paid such close attention. Because the most unsettling moment wasn't fire or ash or lava. It was a change in the signal. A mountain that had been quietly swelling and shaking suddenly started breathing differently. And for volcanologists, that can matter more than anything you can see from the ground. Out on the west side of Cook Inlet, about 80 miles from Anchorage, Mount Spurr looks like what people imagine when they think of Alaska. Ice, silence, distance, emptiness. But that calm is deceptive. Spurr is one of the highest risk volcanoes in the region, not because it sits next to a city, but because if it wakes up the wrong way, the effects don't stay on the mountain. They spread into air routes, cargo traffic, communities, and the daily rhythm of Alaska's largest population center. And the strange part is this. The warning signs didn't arrive as one dramatic event. They arrived like pieces of a pattern. First, the ground started to move. Not enough for anyone standing there to notice, but enough for instruments to catch it. GPS stations showed the surface shifting outward from the volcano by more than 2.5 inches. That may not sound like much until you remember what it means. Mountains don't gently puff outward for no reason. Something underneath was pushing. Something hot. Something with pressure. Then came the earthquakes, not the kind that knock over shelves, the kind that whisper through rock. Hundreds of them, then thousands. By early 2025, more than 3,400 earthquakes had been located beneath Mount Spurr since the previous spring. At one point, scientists were seeing over 100 per week. Most were shallow. That detail matters. Deep quakes can mean movement far below. Shallow quakes suggest the system is changing closer to the part that can actually break open. But even that wasn't the part that made experts lean forward. The real shift came from the air. When scientists flew over the volcano and measured the gases coming out of it, they found sulfur dioxide had jumped dramatically. In December, emissions were under 50 metric tons per day. By March, the summit vent was releasing around 450 metric tons per day. Carbon dioxide was elevated too, especially at Crater Peak, the vent 2 miles south of the summit where all of Spurr's known historical eruptions have actually happened. That changed the story, because earthquakes can happen without eruption. Ground swelling can stall. Heat can build and go nowhere. Mount Spurr itself did that before. Back in 2004 to 2006, it showed unrest, melted part of the summit ice, and still never erupted. So if this were only about shaking ground and a restless mountain, scientists would still be cautious, but not necessarily alarmed. Gas is different. Gas tells you magma may not just be sitting there. It may be opening roots, finding cracks, pressurizing pathways toward the surface. And when the gas results came in, experts started saying something they hadn't been saying before. An eruption in the coming weeks or months had become more likely. That's what made the signs unusual. It wasn't just more activity, it was the way the activity lined up. Think of a volcano like a locked room. Earthquakes tell you someone may be moving inside. Inflation tells you pressure is building against the walls. But gas? Gas is smoke under the door. It suggests the inside is connecting to the outside, that the system may no longer be sealed. And Mount Spurr added one more detail that made the whole picture harder to ignore. At Crater Peak, scientists saw diffuse steaming from small snow-free spots starting in March. That may sound minor, but those spots hadn't visibly steamed since 2008. On a glaciated volcano in Alaska, a fresh patch of warmth showing through snow is not just a visual oddity. It's a clue. It means heat is reaching places it wasn't reaching before. So now the mountain had checked multiple boxes at once: swelling ground, sustained earthquakes, elevated gas, renewed steaming, and continued collapse of snow and ice into a crater lake formed during the unrest. That combination is what turned a distant volcano into a live problem. And here's where the story gets more dangerous than most people realize. The biggest threat may not be the summit people picture when they hear the name Mount Spurr. The summit itself hasn't had a known eruption in more than 5,000 years. The vent with a history is Crater Peak, off to the south. That's where the eruptions in 1953 and 1992 came from. So while the giant summit gets the attention, the vent with the proven record may be the one that matters most. That changes how you think about danger. Because the real threat isn't some slow-motion lava disaster crawling across the landscape. It's an explosive ash event. In 1992, eruptions from Crater Peak sent ash columns tens of thousands of feet into the sky. Ash fell over south-central Alaska. Anchorage dealt with gritty air, darkened daylight, and airport disruptions. And volcanic ash isn't like fireplace soot. It's pulverized rock, sharp, abrasive, destructive. The kind of material that can turn jet engines into liabilities. That matters more in Alaska than almost anywhere else. Anchorage isn't just a city under a possible ash plume. It's home to one of the busiest cargo airports on Earth. If ash gets into those routes, the impact doesn't stop at canceled flights. It starts touching supply chains, mail, freight, medicine, movement. A volcano 80 miles away can suddenly become a problem measured in far more than miles. And yet, just when the story seemed to be narrowing toward eruption, it twisted again. By April, some of the signals eased. Earthquake rates dipped. Ground deformation slowed, even paused. Weather made gas measurements harder, which added uncertainty, but the clean escalating pattern from March became less clean. Scientists said the likelihood of eruption had decreased from where it stood earlier, even though the volcano remained above background unrest. In other words, the mountain was still abnormal. It just wasn't advancing in a straight line anymore. That may sound reassuring. It isn't. Not completely. Because a volcano that races toward eruption is scary. But a volcano that advances, hesitates, and leaves experts debating what comes next can be even more unnerving. It means the system is active, but not simple. Magma was still believed to be under the volcano. Deep earthquakes suggested that activity hadn't fully gone away. The mountain had not returned to normal. It had become uncertain. And uncertainty is where public attention usually drops off. That's the mistake. People know how to fear an eruption. They don't know how to fear a process. But volcanology is mostly process. Pressure, fluids, fractures, heat, timing. A mountain doesn't usually go from peaceful postcard to apocalyptic blast in one clean cinematic jump. It sends signals, then mixed signals, then stronger ones, then sometimes nothing, then sometimes everything. Mount Spurr for a while looked like a textbook escalation. Then it looked like a stalled intrusion. By late spring, scientists said the magma driving the unrest had most likely stalled. By August, the alert level was lowered back to normal. So was it over? Maybe in the short term. But that isn't the same as meaningless, because the point of all this isn't that Spurr erupted. It's that it changed. It showed scientists a living system reconfiguring beneath ice and rock. It demonstrated that pressure could build, pathways could open, gases could surge, and a historically dangerous vent could show fresh signs of heat again. Even without a major eruption, that is valuable intelligence. And from a hazard perspective, it's a reminder that the next phase of unrest won't begin from ignorance. It will begin from a volcano that has already shown what it's capable of looking like before a possible event. That's the haunting part. A quiet mountain near Alaska's largest city started giving off the kind of signals experts watch for most closely. Not because they are loud, but because they are specific. The Earth moved outward. The quake count climbed. Gas chemistry shifted. Steam appeared where it hadn't appeared in years, and for a moment, the pattern suggested the mountain might be preparing to do what it has done before. Then it stopped short, at least for now. So if you're waiting for the scary part to be the explosion, you're missing what makes volcanoes so unnerving in the first place. The real fear starts earlier, when the instruments begin to disagree with the landscape, when the mountain still looks frozen and silent, but the data says it's breathing harder. When experts stop talking about what a volcano is and start talking about what it may be becoming. That's what changed at Mount Spurr. Not the skyline, not the postcard view, the hidden conversation underneath it. And somewhere beyond Anchorage, beyond the cargo routes and the weather and the cameras aimed at an ice-covered peak, that conversation hasn't been forgotten. Because mountains like this don't need to erupt to prove they're dangerous. Sometimes all they have to do is start acting like they remember how.